Yo, yo, y'all. Here we go. We're cracking down like it's cool. Okay, so we have some new formulas, and they're called power reducing formulas because it takes a power of 2, and when you take sine squared, it reduces the power to just a power of 1 now. So this is the formula, and as you can see here, it no longer has a square. Cosine squared now becomes 1 plus cosine of 2u over 2, but as you can see, again, the square is gone. And that's just what this formula does, and it's useful in many cases. And the example that we're going to do down here is we're going to rewrite sine to the power 4 of x as a sum of first powers. So that means that we want to have some kind of sum at the end, but we want the powers, or also known as we want the exponents, to be a power of 1. And we want to put it in terms of cosine of multiple angles. And again, multiple angle means like this, right? This is kind of like a double angle, triple angle, or something like that. So it could be 3x, 4x, right here. It could be like cosine of 2u, cosine of 5u. Okay, so we have a lot of prereq here. We have to make sure they're in first power, make sure that they're in cosine, and we can have multiple angles. So a lot of little things to think about there. All right, well, let's go ahead and see what we can do with this guy. So we want to rewrite sine to the power 4 of x. Okay, well, first of all, I can rewrite sine to the power 4 as a product, as sine squared times sine squared. Okay, so sine squared of x times sine squared of x. Well, that's the same thing as just saying sine squared of x, take that whole thing, and then square it, right? So these are all equivalent. Now, if you look at our power reducing formula for sine, we can replace sine squared of x with 1 minus 2x over 2. See, 1 minus cosine of 2x over 2. So I'm going to replace sine squared of x with 1 minus cosine 2x over 2. All right? So let's go and try that there. So parenthesis, 1 minus cosine 2x all over 2, and then square that. Okay, so I just replaced this guy with 1 minus cosine 2x over 2, and I put it right here. Okay, well, let's just go step by step here so we're not getting confused here. If I square the bottom, doesn't that just become a 4 on the bottom? And then I'm going to leave the top as a binomial square, 1 minus cosine of 2x squared. Okay, so all I did right there was just I squared the bottom just so that I can just move the square then on top. Okay, so when I do my next line, I'm going to come over here now. I'm going to do 1/4 times now, and now I'm going to square this right here. 1 minus cosine of 2x times 1 minus cosine of 2x. You see what there is? I'm going to go ahead and multiply this out. So this is going to be 1/4. Now I'm going to use brackets now. It's just another form of grouping. So 1/4 times this whole thing. And if I FOIL it out, I'll get 1 minus 2 cosine of x. Oh, cosine of 2x. Oops, let me go ahead and erase that there. Cosine of 2x. Cosine of 2x. And then minus, actually plus, cosine squared of 2x. Okay? Now, if you think, oh, okay, we're done. Well, if you come back up here, what we're supposed to find has to be a sum of first powers. Okay, well, first of all, we have sums. Okay, that's fine. But we don't have first power. We still have a power of 2. So we need to replace cosine squared of 2x. And we're going to use this formula over here. So let's just write down what that formula is right there. Okay, so I'm going to write it right here. The cosine squared of x is 1 plus cosine to the 2x, or times 2x all over 2. Okay, so I'm just copying down what I wrote right here. Okay, so I'm just writing the rule down. 1 plus cosine of 2x over 2. Now, if you look at this, our angle, though, is 2x. See right there? This is cosine squared of x. But this says cosine squared of 2x. But that's fine. And let me show you what I mean by it's okay. So basically, whatever is connected with x, that's going to get multiplied by 2. So when I plug this in right here, this will not be a 2x. It's going to become a 4x. Okay, so I'm going to say that again. When I do my power reducing formula, instead of writing a cosine of 2x, because this already has a 2x, I'm multiplying 2 times x. So 2 times 2x will be a 4x. So this whole thing will be the same, except this will be a 4x. So let me show you what I mean now. 1/4 times 1 minus 2 cosine of 2x. Now I'm going to replace this whole thing with plus 1 plus cosine, right? So I'm just copying down this formula, but instead of doing 2x, it's going to be 4x. Oh, wait, but no square now. There's no square there. There you go. And that's all over 2. Oh, dang. That just got super hairliciously crunchy. Okay, now if you go back to the prerequisite up here, let's see. It needs to be written as sums of first powers. Well, that's a sum, and you could think of this as a plus -2. So this is also like a sum right here. But we have a product right here, so we have to multiply this 1/4 through. So I'm going to multiply it through. 1/4 times 1 is 1/4. Now 1/4 times 2 is just minus a half, because 4 and 2, 2's on top, 4's on the bottom. So 2 goes in the top 1 time, and 2 goes into the denominator 2 times, okay? Times cosine of 2x plus, let's see right here, 1/4 times 1 is 1/4 plus, I'm sorry, wait, this is actually over 2, so this is like 1/2. So 1/2 times 1/4 is going to give us 1/8. So that should be a 1/8 right there. So 1/8. And then cosine of 4x over 2, multiply this guy by 1/4. So I'll get cosine of 4x all over 8. Okay, let's see if we've now met all the prerequisites. Rewrite sine of blah blah as a sum of first powers, good, and of cosines of multiple angles. So is it in cosine, and do we have, multiple angles in there? Well, yeah, look, I have 4x is a multiple angle, 2x is a multiple angle, and it's all written as sums. So, and it's first power. So that was pretty hairy. I guess we could do 1/4 plus 1/8, get 3/8, but this right here would be our final answer because it meets the criteria of what we're trying to find.